Hey guys, welcome back. This is the last slide of Module 4, the Brew House. I'm Chris Johnson from Green Bench Brewing Company here in St. Petersburg, Florida. The last thing we need to talk about in the Brew House is wort cooling and aeration. So probably be a pretty quick one. Let's hop into it. So, wort cooling and aeration. We're going to talk about heat exchange, single stage and dual stage heat exchangers, aeration, and the required reading will be Chapter 12 in the Brewer's Handbook. So take a look at that. It's got some really good information. A lot of good information actually about aeration, which I really like. So here we go. Heat exchange. So we talked about this a little bit earlier in the module about heat exchangers, the purpose that they play, how they kind of work. So heat exchangers, as seen in the brewhouse configuration, as I mentioned, are used to rapidly cool hot wort in preparation for yeast inoculation. So before we add our yeast, we need to cool the wort down to a temperature that's not going to kill the yeast. Basically, very thin plates are tightened together that allow hot water to flow on one side and cold water, or hot wort rather, flow on one side, cold water to flow on the other side. This can also be done with glycol. We do it at our brewery, and a lot of breweries now are really using cold liquor tanks more often than using glycol. But regardless, cold water or glycol on one side, the two liquids get very close together, these plates. They exchange heat, and so your cold water will go in very cold. Ours goes in about 40 degrees Fahrenheit, 39, comes out about 170. Our wort goes in about 210 degrees Fahrenheit, comes out about 70. So very rapid, immediate sort of exchange of heat, and that's how the technology works. Here's sort of, this is my heat exchanger at my brewery. I guess I'm kind of in the way there, but you can kind of see the heat exchanger. So this is rapidly cooling down wort with the use of cold water or glycol in a one-plated stage. So this is it. There's just this one. It's a one-stage heat exchange, single-stage heat exchange. Wort goes in, water goes on the other side. That's it. And then the big red sort of hose that's coming out is the wort that comes out cold. Then there's also dual-stage heat exchangers. So a dual stage will look exactly the same as a single stage usually, except you can see, I'm going to go back real quick. You can see here, you can see my mouse on there. All right, you see this big plate here and this big plate here. Often on a dual stage, there's a second plate, usually like right about here. So there's three big sort of steel plates that where the wort doesn't actually go through that plate, it just is a separation. And the way that a dual stage works is that you rapidly cool down hot wort first with water before using cold water or glycol. So for example, sometimes what you'll use is city water, just regular groundwater temperature in a dual stage. So the first bit will bring the cooling or the boiling wort down at least, to 130 degrees Fahrenheit or lower. And then it goes to the second stage, which will bring it down against cold water or glycol, which will bring it the rest of the way down to 60, 70 degrees Fahrenheit. So that's a dual stage. So it goes through city groundwater temperature first, then cool water or glycol. So again, rapidly cooling down hot water first with water before using cold water or glycol to help conserve cold water and or glycol usage. So it's less of a stress on your glycol system if you're running glycol against it, and you use less of your cold water if you at least knock it down a little bit beforehand. Aeration. So wort aeration assists in creating an ideal environment for yeast growth and fermentation. The amount of oxygen added to wort is very much dependent on several factors such as temperature, gravity, turbidity, but the most important factor is the yeast strain selection itself. What yeast you're using is going to really determine how much oxygen you need. Wort aeration stones are used, usually ceramic or sintered stainless, to inject tiny bubbles of air into moving wort. And that's usually post-heat exchange. So most brew systems will inject oxygen post-heat exchange in line to the fermenter. So your tube that's either coming out of the heat exchange or your line that's going into the fermenter, your hose, wherever it is, usually there'll be a stone, a small sort of aeration stone that's placed in line. So as the wort passes over it, it's shooting oxygen out of the stone and into the liquid, like literally injecting the oxygen into the liquid. So most brewing yeast strains, they'll require between 7 and about 18 milligrams of oxygen per liter. And I guess I was a bit repetitive there. 7 to 18 milligrams O2 per liter of oxygen. I guess I didn't have to say of oxygen there. So making an air compressor or with a sterile air filter, that this number will make it fairly adequate. Usually an air compressor with a sterile air filter will push about 8 megs of O2 per liter. So for example, at my brewery, for the most part, we use this. Some yeast strains require upwards of 12 to 20, even more oxygen per liter. So if that's the case, then usually you'll need actual oxygen, like an oxygen tank, and just pump, true pure oxygen into the liquid itself. So as it says here, strains requiring more oxygen should be aerated with pure oxygen for a higher dosage level. Yeah, so that's it, guys. Check out the reading. It's been a good Module 4. If you need anything, let me know. Cheers.